Hi, everyone. Welcome to the Streaming Summit 2025. Today, I will share a topic of efficient Kafka topic compaction and scale or Ursa. Yeah, I'm Peng Hui. I'm a director of Stream Native, and I'm leading the platform engineering team to building messaging systems for like Pulsar and Ursa, which is a Kafka-compatible service based on N3, and it will natively connect data to Lakehouse. Yeah, so and before joining Stream Native, I'm a software engineer at Zhaopin.com, that which is the first adoption in China. It's at 2018. So I'm also a POSA committer and PMC member. So like before we talk about how Ursa support topic compaction, let's just take a quick through of what is topic compaction in Kafka or POSA. So the definition is very simple. The topic compaction is the return and the latest value of each key in a topic rather than returning every message indefinitely. So here is an example. You have four messages from two keys, and finally, the topic compaction will remove the old values from the keys, and the latest value of the key is returned. So finally, you will only get key 1 v2 and key 2 v2, and we take key 1 v1 and key 2 v1 deleted from the partition. So there'll be so many use cases for the topics compaction. For example, if you want to maintaining the latest user profile or configurations, it's because the user profile or configurations will be like changed multiple times. And for example, for the IoT industry, it's if you want to manage the IoT device states. Yeah, for example, you want to know the last known location of a device. And for example, have a shopping cart, is you want to know the like the latest items of the quantities. Yeah, there'll be much more use cases. And something like local caching, you want to catch the only the latest state of a key or something. And and I know in POSA internals or Kafka internals, it also used the compacted topic for managing the some metadata or something. Yeah. So with topic compaction, yeah, it's you will be more efficient to recover the state. The consumers can reconstruct the latest state of each key by just reading the compacted topic. Yeah, otherwise, without topic compaction, it's you need to like read all the original logs from the partition, and it will incur like more CPU and network cost from both broker and consumer. And it will also like reduce the storage requirement. It's because like when the latest value of the key is retained for a long term. So like there will be many old values will be cleaned up from the storage. And it also like has a built-in like a key-based duplication. It will automatically like ensure like and the most recent value is returned. So like you can get finally you will get like a compacted view without any like duplicated messages. Yeah, but it's like a default depends on the like configurations or it's not like a guaranteed compacted view after the new message published. Yeah. So So let's just take a quick look of how topic compaction works in Apache Kafka. And it's also the Apache Pulsar is also follows the almost like the same pattern. It's but it has some differences, but the idea is similar. Yeah, first the broker will read the original data or uncompacted data. So it will go first read and then try to build a index or build a map. The key is the method key, and the value is the offset in Apache Kafka, and the method ID in Apache Pulsar. So after you go through the first round, you will get like an index map, and then you can use the index map and try to do a second read of the original log or uncompacted data, and you can filter out the the old values. So finally, you will only have the only the latest value, just write into the new segment, or in pulse it will be write to like a new ledger, and then the broker can replace the old data segment with the new data segment. So yeah, the old segment will be removed finally. So so what is the topic compaction guarantees? Yeah, the topic compaction, with topic compaction, you will able to get the latest value per key, and the latest value per key is always returned. It will not be removed until you try to remove it manually. And the old records with the same key are eventually deleted. And if you want to delete a record, and you need to put out a temple store, or just a record with the same key, but the value is none. And the consumer can always replay and rebuild the state, with the state means the latest value of the key. And you need to know that the compaction is running sequentially, so there is no strict timing guarantees. So you will eventually get a compacted view without any old values, but this is no strict timing guarantees. So let's move to topic compaction or Ursa. Yeah, Ursa is it's a Kafka. It's a Kafka compatible service, but it will have unique challenges and opportunities for implementing the topic compaction, because the major reason is there is no a single leader for partitioning Ursa, and the second one is there is no local disk for Ursa. So if you want to read more data from the cloud storage, you will pay more cost for it. So the major denied goal for Ursa topic compaction is cost effectiveness. So Ursa leveraging the S3 object compatibilities can also optimize the compaction by efficiently managing and deleting the old values. So we also need to ensure the data durability and availability, but to ensure the cost effectiveness, essentially we need to reduce the S3 request. In Kafka, you have a local disk, so it's fine. You can just read the data multiple times from the disk, because you already pay for the disk provisioning. Yeah. So and the second one is about we want to design the topic compaction or size more like efficient and more scalable. So because it's if you go back to the like top Kafka topic compaction, yeah, it will like read the data like twice, like for building the index and create the like new segment. And if you have like a lot of case, yes, it will be costly and inefficient and maybe not like you can also like scale it by like adding more partitions. Yeah, but we just want to like find a solution or Ursa like to make it more like easier to scale and can make it like it can handle large volume of data and the large amount of case. So before we dive into the details of the topic compaction solution Ursa, it's just introduce a little bit about the Ursa state compaction service. It's because the topic compaction is also like based on the like copy compaction or build upon the compaction service. Yeah. So yeah, in Ursa actually like both like Kafka producers are just like writing the data to the WAL log. Yeah, WAL log is means just the first is raw data, and the second is the data from multiple topics will be mixed in one like S3 object. So why we do have like a WL log, it's because they like cost, like we want to reduce the S3 API cost. So like we cannot like have a one S3 request like per topic. So and the Kafka consumer can also like either like read from the WL log or like read from the compacted data. So the compacted data here is just like the compaction service will just try to compact the data from WL log to like lakehouse tables. Like we will map like a Kafka topic to a lakehouse table, and like a Kafka consumer can also read from the like a lakehouse table, and you can also use like a table API to just query data from the table. So in the like compacted data, we just use like a columnar format, it will be much more efficient for analytics, and it will also like reduce the storage size. So in Ursa, like we will only have like a single copy of data for both like table and streaming API. Yeah, so this is what like data compaction service do in Ursa. Yeah, so why this is related to compaction service is because like we want to like introduce a solution which can like reduce the S3 request as much as possible. So we will introduce like minor compaction and major compaction to the compacted topic. So and I will show you like how it works. Yeah. So first, like for example, like you have 7 messages right to the topic, and then like the compaction service will try to like it's maybe those topics came from like sorry, those messages came from different topics or same topics. It doesn't matter. Here is just like an example. Here is from like a same topic. So the compaction service like will try to do a like a minor compact. It will just like read the data. It's before read the data from WL log, and like before it compacted data to lakehouse table. Like we will build like a compaction method. Actually, this is also the same one as like a Kafka topic compaction. It's just like a build a map or like an index. It's the key is the message key and the value is the offset. And during the minor compact, and like we can also like filter out the message with the old values of a key. So for this example, we have like three keys, but we have like seven messages. So during the minor compact, like we will only write like three records to the lakehouse table. So and then like more and more messages will be written to the topic, right? So we have another like seven messages, and then the compaction service will try to like do another minor compact. So in this case, like like only the message with offset like 10, 12, 13 will be written to the compacted data or lakehouse table. Yeah, but since for now, like we have two compaction metadata. Yeah, the first one is the 3 keys, and the offset is 4, 5, 6. But if we compare like the two compaction metadata, like actually like we know like which record should be deleted, right? Because like we will not like go back to revisit the old data. So we just like read from the metadata, and the metadata can like store in the metadata service. We use the OCR for the Ursa metadata service. So like based on the metadata, like we can know the deleted offset. Like in this case, like the offset 4 and 6 should be deleted. So yeah, after we know the like two two metadata sorry, two compaction metadata, and then we can like merge the actually just like merge the compaction metadata. And when consumer like try to like read the message from the partition, like Ursa will filter out the filter out the message based on the deleted offset. Yeah, I mean in this case, consumer will only get the offset with 10, 12, 13. The message with offset like 4, 5, 6 will be filtered out. So consumer will not receive those messages, the old values. And because like Ursa use like a separated system for managing like data at the index. So in this case, like Ursa will not like read messages like from S3. It just like read the index and try to like filter out the offset. So it will only like read the data for the offset need to be delivered to the consumer. Yeah, so this is what major compaction do. So let's give like a summary of the major compaction. Yeah, first it's just like read from the WL log and create the compaction metadata and write the compacted data and create the deleted offset. So you will see all the result here. It's yeah, for example, like merging the metadata and get the new metadata and the deleted offset. So like with a minor compaction, actually the consumer can get the latest value of a key, but like now you should you can see like there is a issue. It's like how can we like remove the old values, so remove the old values from because we do like a different we do multiple minor compactions. So how do we remove the data which has been added to the deleted offset? So it's let's talk about the major compaction. Yeah, so this is the issue. For the first minor compaction, we will write 4, 5, 6 to the compacted table, and the second minor compaction we will write 10, 12, 13 to the lakehouse table. Yeah, but how do we remove 4, 4, 5, 6 since it's not used? It will not be it should be removed finally. So yeah, based on the compaction metadata and the offset. So a major compaction is just try to clean up the do the data cleanup to remove the messages with the old values. So for now, we have two compaction metadata, and then the my major compaction can merge the compaction data first, so we can know the latest compaction metadata for this partition, and then we can the major compaction just clean up the data first and then merge the compaction metadata, and the last one is just to update the deleted offset. So after the major compaction done, it's we clean up everything before offset 13. Yeah. So just in summary, it's the Ursa used our way to do the minor compaction and the major compaction. The minor compaction it's happen more frequently. It reduce the cost to S3 since it will not actually touch S3 data. It's just filter out the offsets from index, and the minor compaction also manages the all the compaction metadata and the deleted offset in Oxia. It's just used for filter out the outdated data. The major compaction actually it can be triggered based on either amount of the data can be deleted, or the number of S3 API calls involved. So it could be we can apply more policies to the major compaction, just to balance the the cost from data storage size or the API costs. Yeah, so the major compaction provided the most cost-effective way to clean up the data. Okay, yeah, this is the talk I shared today. Yeah, thank you.
Awesome. Thanks a lot, Pengwei. That was a great session.
Hey, thank you. Good night.
Perfect. Let me see if there are any questions for you. I don't see any questions.
I think there is one more question. I just answered
I see. Okay.
in the chat box.
Perfect. Yeah, I think you stayed ahead of that. Lovely. I know this recording is going to be shared with you all after the event, so you can always sort of revisit that and go through the content slowly. But if there are any questions, please let us know in the next few seconds before the next session starts. Okay. Cool. Sounds good. Thanks, everyone, for joining the session today then. I think there are more sessions going on, so stay tuned, hop onto those, and we'll chat soon. All right. Thanks a lot, Pengwei, for
Yeah, thank you.
thank you. Bye-bye.